Hello students, let us solve this Irodov problem, problem number 1.19. A point traversed half a circle of radius r equal to 160 centimeter. What is the question? There is a circle of radius 160 centimeter. A point traversed a half circle. This length circle, this is the initial point, this is the final point. During time interval tau equal to 10.0 second. The time taken by the particle to complete this motion is 10.0 second. Calculate the modulus of the mean vector of the total acceleration. This is a very heavy word. Modulus of the mean vector of the total acceleration if the point moved with constant tangential acceleration. Oh, it means that the particle have a tangential acceleration at and which is constant. So at is constant. What it means that if particle is traveling initially with velocity u, then its speed will changes with time because of the tangential acceleration, and when the particle reaches this point, its velocity becomes something like v. Its speed becomes something like v. Now in the question, neither this number is given. Also this number is also not given. Okay, but I know that this length is pi into r, and the time taken by the particle is tau 10.0 second. Okay, now in case of tangential acceleration is constant, we know that from kinematics the formula is v equal to u plus at. Yes, there is another formula s equal to ut plus half at square. Yes, and there is further one formula v square equal to u square plus 2as. Yes sir, but this formula is valid for when the acceleration is constant, and in circular motion acceleration never be constant. So can I apply this formula? No, we cannot apply this formula. But for tangential acceleration and speed we can apply this formula, because in circular motion direction of velocity and direction of tangential acceleration is always in the same direction or in the opposite direction. So this is the cause of change of velocity. So for between these two quantities we can apply the formula, and s is not the displacement, s is the path length. S is the path length, and v is not the velocity, v is the speed, and a is not the acceleration, a is the tangential acceleration. So what we can write in circular motion for constant tangential acceleration, this become v equal to u plus at into tau. Okay, what this equation becomes pi r. It is not displacement, it is path length. Pi r equal to u into tau plus half at into tau square. Okay, what this becomes v square equal to u square plus 2at into path length pi into r. So I have these three things. Okay, now let me look what is asked in the question. In question, modulus of the mean vector of the total acceleration. So total acceleration, mean vector means it is the average acceleration. Okay, and modulus of that quantity, it means the magnitude. So in question it is asked that the magnitude of average acceleration. So we know that the average acceleration is final velocity minus initial velocity divided by time, and time is tau, and magnitude of this number. Okay. Now, we can write it as magnitude of two vector is under root a square of first vector plus a square of second vector minus 2 into magnitude of first vector into magnitude of second vector into cos theta divided by time tau. Initially, the direction of velocity is upward and finally the direction of velocity is downward. So, angle between these two vectors is 180 degree and cos 180 degree is minus 1. So, this minus becomes plus. So, this will be equal to under root v square plus u square plus 2u into v divided by tau. This is a plus b ka b square. So, it will become u plus v divided by tau. Okay. So, now I have to calculate u plus v by tau. Now, see this. V equal to u plus at into tau. So, I write u plus v equal to u plus at into tau divided by tau. So, it is equal to 2u plus at into tau divided by tau. Okay, this is clear. But to calculate this number, I have to omit this u because in question u is not given, at is not given. So, I have to use some other equation. Now, let us look to this equation. What is that? Take this tau common and multiply with 2. So, pi r equal to tau by 2 into 2u plus at into tau. Oh, so I got this number. This number and this number are same. It means that 2u plus at into tau should be equal to 2 pi r by tau. So, this average acceleration becomes, instead of this number, I can put this number. So, it is equal to 2 pi r divided by tau square. So, the magnitude of average acceleration, total average acceleration is 2 pi r by tau square. So, this is the final answer. Now, we can calculate the number by putting 160 and 10. Instead of 160, you can put 1.60 and tau is 10.